What is the definition of volume? You want to have an idea? Yeah?
The amount of space an object takes up.
It's the amount of space that an object takes up. That's the definition we're going to use. Everything that's made of matter takes up space. And for our purposes, we're going to be measuring and calculating volume in a couple different ways. The first way we'll talk about is to calculate it mathematically. And this, we only generally use this for regular shaped solids. There are formulas for calculating the volume of a rectangular solid, or you guys call it what? Rectangular prism? Is that the same thing? That was a math. All right. What's this shape? Cylinder. There's also a formula for a sphere. We're not really going to use that one. And there's some others, but we're going to use basically just rectangular, solid, and cylinder. And so if you have a rectangular solid, you could measure its dimensions and then use a formula to calculate its volume. So for a rectangular solid, the formula is length times width times height. Where's the notes, guys? Yeah. Notes. That's what we're doing here. So again, we follow the steps that we followed for area. We write the formula. Volume equals length times width times height. What's the second step?
Put in the numbers.
Substitute in numbers. In this case, 3 centimeters times 1 centimeter times 2 centimeters. Last up, do the calculation. What is it? 3 times 1 times 2?
It's
6. What?
centimeters.
6 centimeters cubed. Centimeters times centimeters times centimeters is
Cubed.
Yes. Volume is in cubic units. Centimeters cubed. Okay, the formula for the volume of a cylinder is pi times radius squared times the height. Okay, so again, we have a cylinder shape here. We write the formula. Substitute in our numbers. We do the calculation. And we get an answer with the units. In this case, 3.14 times 3 squared times 8 is, Dana, what did you get?
226.08.
Right, 226, okay, 0.08 cubic centimeters.
How do you write
A little 3 above the CM. Cubed is to the third power. So for regular shapes, you could calculate it. Okay. Well, for liquids, we use a tool called a graduated cylinder. You guys used graduated cylinders before? Okay. The graduated cylinder is a tool used for measuring the volume of liquid. It's basically a plastic or glass tube with markings that indicate the volume of that liquid. Okay, so pour your liquid into the graduated cylinder. Now, when you do this, because of the properties of water, it will form what we call a meniscus. Okay? It's this curve at the top of the water level. You always read that meniscus from the bottom. So you read the lowermost point of that meniscus to find the volume of liquid. So what is the volume of water in this graduated cylinder? Donovan?
10.15.
No.
No. Can I repeat that? Right, 11.
Don't repeat it because it wasn't right, but
11.5.
11.5? Okay.
Yeah.
Why do you say 11.5?
Because each of the long marks stand for 1, based on my calculations from 5 to 10,
Okay.
and the little marks, that means must be more.
Yeah, you're right. So first off, what does this 10 go with?
What?
Where is
Oh,
it?
that big
Where's the line for
box.
10?
The big line.
Yeah, it's the line all the way across. So those are the major markings. So there's 10. And like Donovan said, these longer lines, like for 15, that'd be 16, 17, 18, 19, 20. So these longer lines are even milliliters. And then the line in between would be half milliliters. So yes, okay, that's 11.5 milliliters. You look at the bottom of the meniscus, it's right at the halfway line, that's 11.5 milliliters. Sebastian?
How is the meniscus formed? Like, how does
It's because of waters. Remember when we talked about surface tension
the putty thing?
and cohesion and adhesion? The water molecules adhere to the sides of this glass tube, so they move up that cylinder a little bit towards the edges. Okay? Graduated cylinders are calibrated to take that into account. Okay? So it's because they're attracted to the sides, and so they sort of go up the sides a little bit. So that's how you measure the volume of a liquid. You also, the volume of a gas is a little different. Gases expand. You know, if you have a helium balloon,
Yeah.
if you let it go, what happens? Yeah, the gases expand and they come out of the balloon. Gases will expand to take up whatever space they are given. So you could compress gases very easily or allow them to expand, and therefore their volume changes very easily. Okay, so generally, we aren't going to be measuring the volume of a gas. It's the whatever volume of the container it's in. Okay, so if you have a propane canister, the volume of the propane gas in there is what?
Size of the
Yeah, whatever the container is. If you blow up a balloon, the volume of gas in the balloon is whatever the size of the balloon is. Okay, so those volumes can change. Okay, now our units for volume, if we're talking about a liquid, we measure in milliliters. If we are calculating the volume by measuring and multiplying, it would be in cubic centimeters. But they are equivalent. 1 milliliter equals 1 cubic centimeter. They're the same volume. You know, if you ever hear about, watch a medical show or something, if they give somebody an injection, what units do they use? Sometimes, but they may say cc, they need 5 cc's of adrenaline, or it'd be a lot of adrenaline. But what does cc stand for? Cubic centimeter. It's the same as a milliliter. Now, what if I have an irregular shape? Okay? Let's say I have some shape that I don't have a formula.
Take a lot.
Say I want to know the volume of this clippy thing. Is there any formula for the volume of a clippy thing?
No.
No. So how can I figure out the volume of this?
Measure it.
But how would I measure it? But there's no, it has no sort of even It's not a regular shape, so there's no formula I could plug my numbers into. Train?
Kind of like break it down into regular shapes.
You could try that, but it's so irregular, I think that'd be virtually impossible. Donovan?
You could put water in a graduated cylinder and then see how much water you put in at first, then put that thing in and see how high it goes up then.
Okay. If I have a graduated cylinder with a certain volume of water in it, and then I put this in the water, what happens to the water level? It raises. The amount it raises is equal to what? The volume of this object. If you go, let's say you get in the bathtub, you fill it all the way to the very top in water. So it's right at the edge. And then you get in it. What happens to the water? It comes pouring out. Let's say you were able to capture that water. You got a little tray underneath your bathtub. So you get in the bathtub, you fill all the top. Get in the bathtub, you put yourself underwater, you capture all the water that comes out of the tub, then you get back out. If you measure the volume of water you captured, what is that equal to?
Your body's volume.
Your volume. Okay. This is called water displacement, and that's what we do. So, if it's an irregular shaped solid, we use water displacement. Basically, we put a quantity of water in a graduated cylinder. So the amount is really not important. It just needs to be enough to hold the object. Step 2, we record the volume of water. Step 3, what do you think it is?
Put the thing.
Put object in the water and record the volume again. Last step. Train?
You like subtract the two numbers.
Subtract, and that's the volume of the object. So that's how we find the volume of an irregular object. Put some water in a graduated cylinder, record the volume. Put our object in, record the new volume, subtract the two. And that's going to give us the volume of the object. Okay, an example, if I put 55 milliliters of water in a graduated cylinder, I put a small rock in there. Okay, if the volume goes up to 63 milliliters, what's the volume of the rock? 8 milliliters. Common sense. That's volume. And this is your homework.